In this problem, we're asked to find the area of an isosceles triangle, and you're given the integer side lengths for this isosceles triangle. You might be tempted to use what's called Heron's formula, which would be an okay way to do it, and a successful way to do it. But it's also important to know a little bit more about isosceles triangles, and that is when you draw in your isosceles triangle and you get two sides with length 12 and one with length 16, the altitude or the height of that triangle from the vertex, which is the point between the two congruent sides and the base, forms two congruent right triangles, which means that this length is 8 and this length is 8. And so we can find the height using the Pythagorean theorem. 8 squared plus h squared equals 12 squared. Subtract 64 from 144, you get h squared equals 80. Which when you take the square root of, you get h equals, well, 16 goes into 80, so it's going to be 4 root 5, because root 80 is root 16 times root 5. And so the height's 4 root 5, and so if you want to find the area of any triangle is the base, which in this case would be 16 times the altitude, or the height, which we just calculated to be 4 root 5. 1/2 times 16 is 8, so you get 32 root 5. And so it's all about creating the right triangle by drawing in these two right triangles that are congruent by drawing in the altitude to the vertex of an isosceles triangle. You could also, on this problem, do, there's some extensions to this that will fit in with some later ideas of areas of triangles. You could use Heron's formula, and then you could also calculate what the height is to the one of the 12 length sides, because now you know the area, so you just would do 1/2 times that length times 12 has to equal 32 root 5.